This video is about limiting reactant problems and the 3 different methods we talked about for solving those. So the first method we're going to do is finding the amount of product each reactant can make, and then you compare them, and the smallest one is your limiting reactant. The second method is to pick one reactant, find out how much of the other you would need, and then comparing to see if you have too much or not enough. And the final method is to change each reactant to mole per reaction as written, and whichever gives you the smallest number is your limiting reactant. Right. To understand these better, we really need to look at an example. So down here, I've got a problem. And first thing we need to see is how you know this is a limiting reactant problem. And the way to do that is to see if you're given 2 different amounts of reactant. If you're given 2 different values, you know this is a limiting reactant problem, because chances are one of them is limiting and one of them is excess. The odds that you've been given the exact stoichiometric amounts, in this case 2 to 3 moles, is pretty slim. So once you see 2 amounts, you know you have to do one of these 3 methods. Alright, so let's have a go at this. Okay, method 1 is to take each amount of reactant, so we have 1.35 grams aluminum and 2.24 liters of chlorine reacting, and see which one makes us the least amount of product. So I'm going to start with the aluminum, 1.35 grams of aluminum, and before I can change it to product, I need to change to moles. Whenever you want to go from one substance to another, you can only do it in moles. Put grams of aluminum on the bottom so it cancels, moles on the top, and the numbers that go in there, you know, for grams to moles is always molar mass. So 27 grams for every 1 mole. Once you have moles of aluminum, you can change to moles of product. So I will put moles AlCl3 on the top, and if we look in the equation, you can find your mole ratio, 2 to 2. So in here, I'll put my coefficients. Put this in my calculator, and I get 0.0500 moles of product possible. It's important to fully annotate your working so that I and the examiner know what you're doing, and also so that you know what you're doing, so later, when you're comparing your answers, you don't get confused. Alright, so we've done aluminum. Let's do chlorine now. 2.24 liters of chlorine. I've chosen this problem on purpose because we have volume, and it'll be good practice to change from liters of chlorine to moles of chlorine. And this is the one you need to have memorized. At standard temperature and pressure, 22.4 liters of any gas is 1 mole. Then we are good to do our mole ratio from chlorine to product. Again, look up in our equation, there are 3 moles of chlorine for every 2 moles of product. So 3 to 2. Put that in my calculator, I get 0.0667 moles of product possible. Alright, now it's the time to actually think. So we've got 0.05 possible if all aluminum reacts, 0.06 if all chlorine reacts. So it's clear that this one, the aluminum, is my limiting reactant. Now we're not quite done. This problem has asked us for mass of product, and I've only found moles. So we need to do one more quick step. Take the moles, 0.0500 moles of product, and change it to grams of product. Moles will cancel. Again, we need molar mass, and luckily they've given it to us up here, 133 grams. So 133 goes with the grams for every 1 mole. Put that in my calculator, and I get 6.65 grams of product. Notice 3 significant figures because of the 3 significant figures in the amounts, the 1.35 grams. And we're done. Alright, here we go. Method 2 is to pick one reactant and find out how much of the other reactant you would need. So I'm just going to go in the order it's in. We're going to take our 1.35 grams of aluminum, figure out how much chlorine it would take to fully react that mass of aluminum, and see if we have enough. So 1.35 grams of aluminum. Again, can't do anything with grams. If I'm going to convert to chlorine, my first step is to get rid of that and turn it into moles. So same conversion factor we did on the previous example, 27 grams per mole. And now we do our mole ratio. Now this time I'm not going to product, I'm going to chlorine. So we need to look at our mole ratio. It's 2 aluminums to 3 chlorines. 2 to 3. And you might be tempted to stop here, but I don't think moles of chlorine is my most convenient unit. Since I've been given 2.24 liters, I'm going to go ahead and change to liters of chlorine. And that way I can easily compare to the 2.24. So this is the number we'd memorized. 1 mole of any gas occupies 22.4 liters. And if I put all that in my calculator, I get 1.68 liters of chlorine needed. Again, annotate your work. That's how much I need to react with all this aluminum. Alright, so the question is, do I have enough or do I have excess? And if we compare 1.68 liters to 2.24 liters, it's clear that we have too much chlorine. Chlorine is our excess, which means aluminum is our limiting reactant, just like we discovered using method 1. Okay, now we're not finished. Again, we want maximum mass of product. So now that I know which one is limiting, I can use that one to change to mass of product. And we have our final step here to do that conversion. Alright, I've got grams. It's going to look really repetitive here. Change grams to moles. Use your mole ratio from the equation, and this time I can go straight to product because I know that's my limiting reactant. Again, it's 2 to 2. And finally, they've asked me for mass, so I'm going to go ahead and convert to grams. Conveniently, they've given us the 133 in the problem, so 133 grams is 1 mole of aluminum chloride. We'll put that whole thing in your calculator, and you get the very familiar answer of 6.65 grams of product. And you're done. This last method is the hardest to get your head around, and it uses a new unit, mole reaction. RXN is just the abbreviation for reaction. And this means per mole of the reaction as written. So this reaction has 2 aluminums, which means 2 moles of aluminum. If I had 2 moles of aluminum, I'd have 1 mole of reaction as written. If I had 1 mole of aluminum, I would have half of the reaction as written. If I had 4 moles of aluminum, I'd have 2 of the reaction as written. So we're just comparing it to the coefficients they've used to write the reaction. So let me show you how this works. I would take my amount of aluminum, and as always, change it to moles. Can't do anything with grams. So we use our molar mass, 27 grams per 1 mole. Next, I'm going to work out how many moles of that reaction as written do I have. So moles of aluminum on the bottom to cancel, and our new unit, mole reaction, on the top. And I go to my equation. For every 1 mole of this reaction as written, the coefficient of aluminum is 2. So 1 mole to 2. If I put this in my calculator, I get 0.025 mole reaction. I might write for myself aluminum under there so that I remind myself that's for aluminum. Then we do the same thing for chlorine. So we have our 2.24 liters, start there. And as always, change to moles. For gases, 1 mole is 22.4 liters at standard temperature and pressure. And now we can do our mole reaction again. So moles of chlorine on the bottom to cancel, and mole per reaction as written on the top. For chlorine, it's a 3. 3 moles of chlorine for every 1 run of that reaction. So put a 3 in here and a 1 up there. Put that in your calculator, you get 0.033 mole reaction if all the chlorine reacts. And then we just look. So if this reaction ran, we could do it 0.025 times with all that aluminum. We could do it 0.033 times with all the chlorine, which means the one that's limiting us, as we've discovered in all the methods we've done, is the aluminum. And the chlorine is the excess. Okay, so now that we know the mole reaction, we can work out the maximum mass of product. Here's how you would do that. Take the mole reaction of your limiting, 0.025, and change it to moles of product. So mole reaction cancels, moles of product on the top. You look at your equation again. It's 2 moles of product for every reaction as written. And finally, change to mass, which is what they've asked us for. To grams. They've given you the molar mass, 133. And when you put this in your calculator, you get your exact same final answer, 6.65 grams of product. And you're done.